Hey guys, my name's Lochlainn. I studied in 2009 and I went to the Blue Mountains, Springwood High School, and I got a band 6 in engineering studies. Today I've just got a real simple statics question for you guys, but the way I set out the question is what I'm trying to make is the most important part. So in engineering, you know, there's the 5 modules, it's a lot to learn. So a really good way to help you remember so much is to have a really good method on when you're attacking these questions, and it's called, in uni they call it the engineering method, but for you guys I'm just going to break these type of questions into 3 steps, and if you follow these 3 steps every time, it should remind you when you're in the exam under a high stress situation, and you should be sweet. So here we've got just a fixed support and a roller support. It's really important to have everything labelled when you draw these pictures, so I'm going to label this guy A, this guy B, and as you guys hopefully have learnt, a roller only gives a reaction in the Y. In the Y, so we're going to have a reaction B, Y. And the fixed support gives 2 reactions, RAX and RAY. I like to just make everything clear like that, so when I'm starting to solve the problem, I can hopefully not make any silly mistakes. Alright, so when I do these methods, I always remember that someone has to mark this, and the neater it is, the happier they're going to be. So normally I write the steps that I'm doing, and I keep my connotations really simple. Alrighty. So step 1. So for these type of questions, we need to sum our moments around one of these 2 points. It doesn't really matter which one you start with. I'm going to start with A. So if I keep my... Alrighty. So this is pretty much one of the biggest rules in engineering, and because this is a statics question, nothing's actually moving in this problem. So all sum of moments should all equal 0. So what that pretty much means is that when we're looking at this beautiful bridge, these forces are all going to cancel each other out, and the forces that aren't cancelled out are absorbed by our 2 reactions. Alright, so I'm just going to quickly write down the summation of the reactions around A. This first line, something that I always like to do just so I don't make any silly mistakes, is all my distances I put into brackets. So as we know, a moment is a force times a distance. We have our 2 forces here on the bridge and our distances here. So all the distances are put into the brackets, and the forces are just multiplied by each of the distance. So the important one that we're trying to find, because we're trying to find the reactions, is this RBY. What we now can do is just solve for this RBY and make it the subject of the equation. This is really important that when we're dividing everything across, and we want to know silly mistakes. So normally I try, when I'm especially in an exam, I try not to skip any steps, so I'll write out each step until I get to that RBY. Alright, let's do that. Alright, so my first step was just to, because this is a negative, so I haven't really explained that. With the positive and negative with a moment, there's a really good trick. Alright, so because I'm summing my moments around this point A, and we'll first just look at this force here. This is the 2.5 force. So if we say that this is our fixed support and our moment is acting here, that's meant to be a triangle, 2.5. If we put our finger on that point where we're acting around, and then we push our paper or our pen or whatever we want to use up from the point where the force is acting, we can see that the moment is twisting it this way. Right. So my convention, not everyone's convention, is this. Everything that swings in the opposite direction to this is positive. So for this case, this one here, the 2.5 kilonewton force is a negative, and that's what I've got here. This one is swinging the other way, so that will pull our piece of paper down. That's positive, like I've said here, and the reaction RBY is acting upwards, so that's a negative as well. So that's why I've got this negative here. Alright, so I've added this to both sides to get it on the other side, and I've just done these two caps here and here. I've added these together and divided 7.5 across, and I've got my RBY. Alright, so that's the end of step 1. Step 2 is a little trick to speed up your calculations to find reaction RAY. Alright, so step 2. This is the next really important rule for engineering. So again, this is a statics question. So all our moments around that point are going to equal 0, and all our forces, so the 2.5, the two reactions, are all also going to be equal to 0. Right. So instead of summing all my moments around B and doing the same calc again, which is pretty long-winded, I'm just summing the forces around in the Y direction. So all I need to do is look at all the forces that we have. We now know our RBY as 0.86. We have these two guys, and our RAY is the only unknown. So the only way these equations work is if you've only got one unknown, and you know the rest. That means they're nice and easy to solve, like we've done. So, alright, so as you guys can see, those two cancel out. We're left with 0.86 plus RAY. So I'm going to subtract this to the other side, or subtract this one actually, and that leaves RAY is equal to negative 0.86. So instead of doing all this again, I've just quickly done a sum of forces in a Y direction, and it's given the answer straight away. Alright, so this is a really important step that a lot of people forget. Because this is a fixed reaction, it also has a reaction, it has the capability of having a reaction in the RAX direction. Alright, so step 3 is summing the forces in the X direction. That's going to be my positive. Sum of forces in the X direction is equal to 0. Alright, so in this case we can see that there's no external reactions acting in the X direction. So pretty much summing these is RAX is our only force plus 0 is equal to 0. And that pretty much means that RAX is equal to 0. So this is a pretty simple question, but what I'm really trying to stress is that if you guys just keep it really clear and really clear to yourselves, have these 3 steps and write everything with your connotation, use your own little tricks just so you don't make any mistakes, you should be fine in your final exam. Alrighty guys, so make sure you check out all these resources that we have on the website, and you can add any that you want, and good luck in your HSC.